All right, factoring today. We're going to see a bunch of different ways to factor and a bunch of different scenarios to factor. I'm going to be referencing the money flow chart. I don't have it up on the board, there's just not enough room, but if you're in my class, you should have it. So as I go through my steps, I'm going to be continuously referring to that, okay? Let's start with our first one. Now, the very first step of factoring in any case is always GCF. You look for the greatest common factor. What's the most that all terms share? So we're going to start with this one. 15a cubed b squared minus 30ab to the fifth plus 5ab squared. Well, I look for the numerical and the variable GCF here. Now they all share a 5. That's the largest number that goes into all of these, so that's part of my GCF. And if you notice, they all have a's and b's, but the most I can pull out is a single a and a b squared. Notice they all at least have that. You can only pull out what they all have in common. You can't pull out more than that. So I'm going to pull out a 5ab squared. Now, remember, when we're going into a parenthesis, we're multiplying, but if I'm coming out, that's the opposite. We're going to be dividing. So each of these terms are going to be divided by what I just pulled out, the GCF. So 15a cubed b squared divided by 5ab squared gives me a 3a squared. Negative 30ab to the fifth gives me a negative 6b to the third. Now this is where a lot of people go wrong, like, oh, 5ab squared, I pulled it out, there's nothing left. We're dividing. So what's 5ab squared divided by 5ab squared? 1. Now, this is your final answer for this one. You have taken out the GCF. What's left is not factorable at all. That's your final answer. Now, just a reminder, numbers we just divide, no big deal. With variables, you subtract variable exponents when you divide. That's why we're left with 2 a's, because we had 3 and we took away 1. Okay, just a quick refresh. Now, let's take a look at number 2. There's 4 terms. Now, I still look for the GCF. Now, when I say there's no GCF, what I mean is there's none greater than 1. 1 is always at least your smallest GCF that you can have. So there's no GCF greater than 1. When there's 4 terms, we go down the flow chart, GCF. Next, you talk about how many terms there are. If there's 4, we do our grouping method. We group the fronts and the backs. Now, I look at what the fronts have in common. GCF, just like we just finished. 4 and an a squared. That's the most that they have in common. So I'll be left with an a minus 7. I do it to the back group as well. They have only a 3 in common. So I pull out. Now I recommend whatever you pull out, put the sign in front of it. It's a positive 3, leaving me with an a minus 7. Now if you notice, I really only have 2 terms here. This represents one term, that represents the other. They now both share an a minus 7. So I can pull that out because they share a minus 7, leaving me with 4a squared plus 3. And that is my final factored form using grouping. Now, let's move on. 2 more examples. Now, these are both trinomials. We have 2 different approaches when we have trinomials. First off, GCF. Always look for it. There is none, other than 1. Next, if you look at the flow chart, after GCF, how many terms? 3 terms. After that, there's another question. Does your a value equal 1, or is it greater than 1? Now, the a value referencing the standard form of a quadratic, ax squared plus bx plus c. My a value is 1, b is negative 7, c is negative 3. All right, this is our first action step. So you did GCF, there's 3 terms, a equals 1. In that scenario, factors of c that add to b. By the way, my c value is negative 30. I think I said negative 3 earlier. My c value is negative 30. I need to find factors of negative 30 that add to negative 7. Now you can do an exhaustive list here, or hopefully you're good enough to go straight to mental math and just start running scenarios. I come up with negative 10 and 3. That's the only combination that multiplies to negative 30 and adds to negative 7. Here's the beauty about this scenario. When it's a trinomial and a is 1, you go straight to your factors. Factors of x squared are x, and the factors of negative 30 that I want are negative 10 and positive 3. Done. If you're ever not sure, if you're going through these and you're like, I don't know if I did it correctly. Well, keep in mind, these are factors of that. Meaning, if we multiply this together, we should get right back there. So if you're finished and you're not sure, multiply. If you get back to the original, you're fine. If not, something went wrong. Okay? Almost done. Fourth example. Look for the GCF. None other than 1. How many terms? 3. What's your A value? 6. Okay, we're in a brand new avenue now. When the A value is greater than 1, there's a different scenario. If you're reading your flow chart, it says find factors of A times C that add to B. So I have to do 6 times negative 4. So I'm looking for factors of negative 24 that add to positive 5. Factors of negative 24 that add to 5. Again, make your exhaustive list if you'd like, or start running numbers in your head. Mental math, I come up with 8 and negative 3. That is the only combination that multiplies to negative 24 and adds to positive 5. Use your flow chart from here. It does not go straight into the parentheses like it did in the previous problem. We're not allowed to throw that right into parentheses. If you look at the flow chart, your very next step is to rewrite the middle term. You use the same exact expression, the same polynomial, but instead of 5x, it has to put a positive 8x and a negative 3x. The outsides don't change, okay? That's important in this step. You only rewrite the middle term. The 6x squared doesn't change. The minus 4 doesn't change. How many terms do we have now? 4. So we can use grouping, which is exactly what I'm going to do. I look at my front group. Their GCF is 2x. I pull the 2x out. We're left with 3x plus 4. Now looking at the back group, it doesn't appear as if they have a GCF other than 1. Now 1 is the GCF, but I need to get identical quantities. So in this scenario, I'm going to pull out the negative GCF. The reason being, it helps my purpose. My goal is to get identical quantities. Well, I have to do a sign change. So that's why I'm pulling out a negative 1. Again, when you pull things out, you're dividing, which leaves me now with a 3x and a positive 4. That's what I wanted. I wanted those identical quantities. Now, because they share 3x plus 4, I can pull that out, which leaves me with 2x minus 1. Quick rundown on how to factor both trinomial scenarios. Last one. Okay, number 5. We have 16x squared minus 36. Now, what do you look for first? GCF, that's right. Hopefully you said it. And there is one finally. There is a GCF here. So I look at 16 and 36. 4 goes into both of them. So I'm going to pull the 4 out. I'll be left with 4x squared minus 9. Okay, 4x squared minus 9. Now, we haven't seen this yet. We have a GCF, and now there's left with 2 terms. If you're using the flow chart, the 2 term only has one option for us right now. Difference of perfect squares. Difference meaning subtraction, and hopefully you know what perfect squares are. We have a difference, and we have perfect squares. When we have that, we're allowed to use our formula. The 4, don't forget that, is still on the outside. But when we have an a squared minus a b squared, the square root of the front goes in the fronts. The square root of the back goes in the back, plus or minus. Here's what that means. Square root of 4x squared is 2x. The square root of 9, 3. Plus, minus. Done. That is a quick tutorial on how to see factoring in 5 different ways. Hopefully it helped.